The notion of a half-life is the idea that T1 half is how long it takes for half of your stuff to disappear. So in other words, a time such that the concentration is half of the original concentration. And T1 half is useful especially for first order reactions where it's a constant number. So let's go ahead and look at T1 half for first order. So for first order, we remember that the concentration is equal to the original concentration times the exponential minus kT. So if we were to do it at 1 half-life, we could say at T1 half, we know that the concentration is equal to half of the original concentration just by definition. So we can say A naught over 2 is equal to A naught e to the minus k T1 half. And then we can just divide both sides by A naught and then take the logarithm of both sides. And if we multiply through by -1, that's the same as flipping that logarithm. So we get the log of 2 is equal to kt, and then we could just divide by k, and we get an expression for the half-life. So for a first order reaction, the half-life is a constant. So the faster the reaction, the shorter the half-life. It's not so simple for other orders of reaction. So for instance, if we had a 0th order reaction where we had A is equal to A naught minus KT. So in this case, when we write the equation, this is, remember, 0th order. A is equal to, so if we're at, if we're at 1 half-life, then we can say that we've got A naught minus KT. So in this case, we've got this expression, but when we try to solve it for T1 half, we get A naught over 2 minus A naught is equal to minus K, this is at T1 half, of course, K T1 half. And we can factor out A naught, and we multiply through by -1, and this is just going to be 1 minus a half K times T1 half. So when we solve that for T1 half, we can see that it's just going to be equal to A naught divided by 2 divided by K. So in this case, we can see that the half-life is actually going to be longer if we have more stuff. So this is completely different from first order where the half-life was just a constant. And actually, this will be true for other orders of reactions too. So if you did this same analysis for a second order reaction, you'd seen that the half-life actually is a function of the initial concentration. And in that case, it actually goes down with the initial concentration. So half-life is only a single number if we're talking about first order reactions.